Hey everybody. So, today's one's going to be a bit short and sweet. I hope so, at least. So maybe about an hour. Just gonna do a brain dump of like my thoughts about AI decision making, sort of things that I've been through, things that I've struggled with, and kind of my ideas for how to move forward based on like what I've built in the past. At any point, if anybody has questions, jump in, and I'll try to answer as it goes. So we're going to start. Basically, the idea that I have is kind of similar to a lot of my kind of thinking. It's a divide and conquer approach. I'm going to go into a lot more details later on. There's going to be a big disclaimer kind of at the start of it. It's like AI and gameplay in general is something that's very, very specific to the game that you're making. There really isn't a one-size-fits-all solution. There is no like, oh, you do this and it's going to be great. It all depends on your game, your needs, your project, your team, that sort of thing. This is why a lot of these sort of generalized approaches to AI just never work. And why, most engines don't really offer a lot in terms of AI or whatever else, because it is just so specific to what you're trying to build. I'm not going to go into too many details because, again, of this kind of gamey nature. I'm going to give a very high level approach that I feel does work for pretty much most types of games, but I'm not going to go into details of like, oh, this is how you build a reaction, this is how you do your transition, this is how you do blah, 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 because that is the part that is very specific to your game. I'm going to give very kind of broad examples. This is more of just getting your brain thinking and kind of presenting a new approach. So there's going to be a lot of like details left out on purpose just to kind of keep things at a conceptual level. So the first thing I'm going to do is I'm going to run through a lot of my kind of past experiences and sort of kind of hint to where this whole thing came from. I've never really seen this in use. That said, it's nothing fancy. It's a very simple, in hindsight, obvious approach to the problem. So I've likely just rediscovered something that, has been used before. I really doubt this is anything new. So let's just jump right in. My first sort of experience with AI was on Hitman Absolution. That was my kind of first AAA project. It was a relatively small team. It was fundamentally using a behavior tree, using a custom language with a custom parser and all this kind of fancy shit. But the reality is we also had a lot of these managers in code. They were called situations. And it was kind of like piecemeal, kind of hacked together as the project progressed and we had to ship. And it became really painful because some decisions were in the trees, some were in the situations, the trees bound to the situations to do things. It was really difficult to know where to change what. And then it was also like built with the assumption that there were only going to be like enemies in the game and guards sort of thing. And then when we had to add civilians and stuff, that became really, really painful. Because like all over the tree, there was a if civilian, if guard, in every single situation, which was like a combat manager, whatever, we had if civilian, if guard. So we had civilians and combat managers just then doing like panic behaviors and shit like this, just because there was no mechanism to split stuff out. It was kind of all shoved in one system, now trying to support archetypes. And there were no archetypes. There was literally civilians and guards, nothing else. Everything else was faked. After that, I was on a new IP Hitman project, which sort of got rebooted into what ended up being 2016. Taking the experience on Absolution, the idea was to kind of basically rebuild the AI because we had different kind of goals at the time in terms of like retrofitting, games as a service, a lot of this kind of stuff. And so I wanted to take a more agent-centric approach. I still thought of behavior trees as a useful tool. I just moved away from this custom language that we had and started building a visual tool. At the time, like planners becoming popular, the HTN stuff was in full craze and everything. So I started going down that path too. But talking to a few folks at other companies and their like pain points with them, I moved away. I also couldn't really figure out how to get them to work for what we were trying to do. This was the first time that I decided, okay, I wanted to basically do composition for AIs, because we had a lot of cases where it's like, I have a civilian, but in this level, it needs to act like this. And in that level, it needs to act like that. The situation, we need these. So that's why I wanted to do more composition. And I started trying to use behavior trees for that by leveraging subtrees and a bunch of stuff. And frankly, this was the one thing that completely burnt me on the concept of behavior trees. Personally, I would never use a behavior tree. I would never recommend anybody use a behavior tree. It was just a very painful experience, and one that just didn't scale. I got it to work, but there was no extensibility, scalability path down the road. And it was just like sort of a dead end. Anything with a lot of pain and suffering can be made to work. But this one, just even in the early stages, I was like, I'm hitting walls constantly with this. I then went to UB. I was on a canceled Far Cry project. At the time, we were based on the FC3, FC4 code base. So I got to kind of look into that. There, they kind of had a bit of everything. They had a state machine that was managing some gameplay state, but then they also had a behavior tree on top of that. And then they had stuff in code. It was just a mess of like everything is everywhere. And on top of that, their behavior tree was a absolute nightmare, at least the one we had on the project. It was like thousands and thousands and thousands of nodes, of subtrees, of links, of implicit stuff. It was insane. If I wasn't completely sort of burnt on behavior trees, this completely did it for me. I was like, okay, this just cannot scale. And the cognitive overload of like bouncing around 50 million like subtrees, trying to figure out what's referenced where, how, and how things like flow, it was too much. Essentially to do something that was very, very basic. Past that point, I've been at Warner, I was at Warner for 6 years. We had initially access to the Arkham Knight code base because, Batman games, whatever. And we were doing kind of a new IP that got canceled. And there they were doing more of a kind of agent-centric approach again with more managers. Luckily, it wasn't a behavior tree approach. They took a very different approach. I don't remember the name, but it was some like paradigm coming from Rockstar Leads, I think. It's kind of a very like also school approach. And that thing was done in a way that it became absolutely undebuggable because everything was just split across. It was just a mess. There wasn't even managers or behaviors. It was just code doing random things at random places. And it had massive scalability issues. The Arkham Knight stuff was way more concise in that it was clear that they had managers that was very kind of, in this situation, you do X, Y, Z. So that one was a much clearer approach, but also very much built to that game and not necessarily super kind of modular. And then I spent 5 years on a new IP project, which is shipping soon. I'm not going to mention which it is, but you can probably figure that out for yourselves. That one, we started out with sort of designer created BTs that very quickly ended up in a giant mess, especially where they wanted a lot of control over very specific things in very scripted scenarios. That didn't work out super well. And then they decided to pivot into a utility system, which, boy, was that a bad idea. It basically ended up being a lot of trying to juggle weights and get binary selection in a system that's supposed to be constantly providing a score for things, and that does not work to drive your overall decision making. Utility has its place for certain, like balancing one action versus another, but building your entire decision making on that is just fucking insane. And at that point, with those experiments, I jumped in and basically re-architected the system to go along the approach I'm going to discuss now. There are some differences and stuff, but fundamentally, what I'm going to describe here is what's being used on the floor there. And it, all in all, worked out relatively well. There are obviously things to production and things change, and things that I would have done differently now, given what I know, but I am still fundamentally convinced that this was the right approach and is still the right approach. And this is what I would do again, given the choice. The other thing is that along the way, because I was still interested in these sort of problems and how to solve it, because I never found a good solution for the most part, I was always talking to other people saying like, hey, how did you solve this? What did you use? A lot of this kind of stuff. A lot of the good info that I got was directly talking to people. GDC talks can be useful. I would put a bit of warning there, is that sometimes the presentations are, it's a polite way of saying it, they're overly optimistic about the reality of what actually happened and the state of what was used. So I would take a lot of those presentations with a big grain of salt, because I know what was presented and I know the reality of certain situations, and they are not exactly aligned. So always kind of, critically parse any information that you get. Anyways, all that aside, let's just cover what the problem is and what we're trying to solve. So fundamentally, all we want is a system that allows us to basically choose the high-level actions that your agents do in a situation. Something happens in the world, I need them to react in this thing, and I need them to play this behavior or do the specific set of actions. It sounds like a very simple thing. And the idea behind all this is that we want to build something that is very simple and fundamentally that is very easy to change. Anybody that's been at the start of a project, you know that like you have no fucking idea what is the reality of where you're going to end up with the project. You might have a very strong idea of what you think you're making, but as the game slowly sort of evolves and you figure out what's fun and what's not and what features you're going to have for the player characters and the AI and this and that, and you realize some things don't work, things will change. The joke is that nobody knows what the project is until they ship it. And that's kind of true in some cases. So I kind of developed this motto that is basically my foundation for everything I do, is that like, that's sort of the thing that I drive home to all of like juniors that I mentor or anything else. It's like, always build something to be changed, architect for change. You don't know what's going to change. So whenever you build a system, sit there and think about it and say, okay, it solves the problem that I have. Now, what if a designer comes to me and says, hey, I was giving it some thought and I'm realizing this feature is not working super well, so we need to pivot in this direction and add this and this and this. How easy is it for you to apply that change to that system? You're going to have to rewrite everything. Are you going to have to hack the shit out of it? Is the system going to be able to even support it, or do you have to kind of like rethink the whole thing? And that's kind of the thought process that gets skipped in a lot of cases, because people they get told I need to do X and they do X. And then X becomes Y, and now it's like, fuck. So that said, another very key point to all of this is, it's a little bit of an aside, but it's important to this mechanism, is that like when you're kind of building the system, it does need to have designer control. They need to be able to work with it. They need to understand it. Same goes for QA and those sort of things. But when you're working with a designer, it can be tricky sometimes because it requires a lot of trust in both directions, right? And that can be difficult to build, especially on a new team. So fundamentally, some guides for this is like, as a programmer, you need to actually listen and try to understand what problem a designer is trying to solve with a specific request. Sometimes in their head, they will ask for one thing, and they won't know how to explain the fundamental core issue that they're trying to solve, right? They'll know how to patch a symptom, but they won't know what the root cause of those symptoms are. And that's where you have to come in and kind of parse that information and say, hey, like you want X. Why do you want X? oh, because the AI is doing this and this and this. It's like, okay, hold on. Why is the AI doing that in the first place? And then you find out that there's a bug or there's something missing or something else is horribly wrong. And you're kind of patching surface level things. That's not always the case, but you need to just sort of listen and try to understand. The main thing is do not try to fix bugs or systemic problems with new features, which is a very common approach, unfortunately, because people to some degree don't dig past the surface level. They think, well, it's doing this, so to fix that, I add, and sometimes you need to remove. Another thing that's super important is you have to extrapolate the future needs and the potential problems from these requests. So it's the way I think of it is like translate what they asked for into what they actually need. Like there's a subtle difference there, but it's more like try to understand why they're asking for what they're asking for. They're not asking just because they're bored and have nothing better to do. There's probably a real reason why. Even if it sounds weird at first or strange, try to understand what it is that they're asking for and why they're asking for it and what they're trying to do with it, right? Because sometimes in a very small request, you'll find bigger problems that need to be resolved that would fix more things than just that. And the other important thing is sometimes you need to learn to say no and say, sorry, adding this is just going to cause too many problems. Let's find a different solution to that. That said, there is two very important things that go with this here. One is never say no without an alternative, right? It's super important to be like, okay, I don't agree with this thing. This is why. These are the problems I think it cause X, Y, Z. Explain why you have a thing and come up with, we can do this in this way or we can do that way. If you don't have an answer for that and it feels weird, the best approach is just saying, hey, I'm getting a weird gut feeling about this. Something's bothering me about it. Give me some time to think about it. I can't give you an answer right now. I need to think about it. I need to like just let it marinate a bit. And then we can pick this up again, right? But never just be like, no, we're not doing that. Why? Because I don't like it or something, like fuck that. So that goes to the second point is just don't be a dick. That's happened a lot of times where it's like you suggest something, somebody's like, no, and it's like, why? It's like, well, because I'm the lead, or it's like, people need to chill the fuck out a little bit. That said, on the designer side, we do need to also teach designers to think a little bit more holistically at a high level. A lot of times they are very focused on details and implementation. And it's like, look, I can figure out the implementation part and then the variables and the math or whatever. Like, what are you trying to do? What are you trying to solve? What is the player experience? What do you want to see? How is it supposed to handle special cases? All this kind of stuff. Like, and that is a much kind of harder problem than just focusing on one little individual design and kind of nailing out 50 million details, right? The real kind of hard things are like, hey, does my design actually work in our environment with the metrics like that? What kind of metrics do we need to provide to LDs for these things to work in the best case? How do we handle edge cases? How do we handle this? Are we scripted? Are we systemic? Those are the things that designers need to be able to have an answer for at like, if you ask them like, hey, are we scripted or systemic? They should be able to give you an answer immediately. I'll be like, oh, well, I don't know. Right. But meanwhile, you have a PowerPoint with like every variable and every fucking value for it. That needs to kind of shift into like, they have the kind of ability to holistically think about the project rather than like the nitty-gritty details where the programmer has the luxury of being stuck in that little nitty-gritty space and just thinking about that. So that whole thing was a very long way of basically saying that like what we want out of the system at the most kind of ideal level is that it needs to be consistent, predictable, and controllable for everybody involved, programmers, designers, and QA. It needs to be easy to be changed, whether that's a small change or a big change. It has to be easy to do that. It has to be debuggable and understandable. That's the shallow learning curve. Like sometimes you get into a new system and it takes you 2-3 weeks to figure out all of the like moving parts. It shouldn't be that way. It has to handle special cases because fundamentally, a lot of the times the special cases take up a large percentage of those cases. It's just that every one of them is special, but they count for like 50% of the gameplay, right? The other thing is that it has to be performant. There's a lot of times where, AI has really, really bad performance characteristics, primarily because of decision making is doing so many things that it shouldn't and touching so much data and all these kind of things that it becomes really difficult to optimize. So kind of from the get-go, you need to sort of think about these things and come up with a way that simplifies things and just allows for performance kind of analysis and also like optimization opportunities. So let's just jump in directly into like the overview. I mentioned it's a divide and conquer approach. And what I mean by that is that for me, at least, there's two main problems that need to be solved by the system. The first one being, what are all the things that I could do as an agent, right? The second one is, which of those things should I do, right? Those are distinct problems. So the first one is the goal or desire generation. I'm going to primarily use the words goal, but you can think of them as desires or opportunities, to use another name that came up. And the second part is the selection, right? So it's those two concrete steps that we're trying to solve. Why divide and conquer? Well, it's often easier just to handle each problem in isolation. So for example, for the first part, it's like, are there any events that I want to react to? Footsteps, explosions, gunshots. Are there any objects I can use? What smart objects around me? Are there any threats? Can I see an enemy? You know, is there like a fire or something? Are there any covers that I could use? You know, query the cover system. Is there anything close by? Those sort of things. Those are very simple things to formulate and to answer, right? And it's also very easy to change the answer by saying, hey, for the smart objects, I am of type blah. Which ones are applicable to me? I want to exclude everything that is marked as only for boss or whatever, you know? Or maybe you say, hey, we want to change the available cover metric to only 10 meters from me or something like that, right? You can change those answers and you know where to change them. It's a very kind of simplistic problem to solve. The other thing is like, once we have all of the things that we can possibly do, like everything that's available for us to do, at that point, it's a lot easier to kind of say, well, given all of the things I can do, what should I actually do, right? It's like, if I have active threats near me, I can see an enemy and stuff. Should I really be reacting to footsteps? Probably not. If I have a cover and a turret and I'm in combat, which one is the better choice? Again, it's a simple question with a very simple answer. You know, depending on your game, depending on your gameplay choices, you can answer that question. Again, if I have a patrol or a smart object, which one do I use? Well, what's my archetype type? What is preferred? Have I been told to prefer patrol versus smart objects? You know, again, there's easy ways to solve those questions. Most approaches that I've seen, unfortunately, tend to kind of mix those into one giant thing, right? There's no concept of this goal or desire. And so as part of the selection mechanism or the decision making, you were sort of generating goals as part of that. Like you're doing queries that then get information, and based if you have the right set of information, then you use that information to run the behavior. But that is kind of problematic in a lot of ways because it becomes very difficult to change this. Because now you've mixed the decision of what should I do with what can I do. And sometimes it becomes very hard to know where to even change anything because let's say it's in one system and you want to change covers, you know, the cover metric or whatever. Should I use a cover? Where do I do that? How many behaviors do I have that use covers? How many of them are querying the cover system? Where do I need to change it? If I change it, do I break anything else? I don't know, because me changing the query for like just pulling in covers, how does that affect the decision-making algorithm? It also has a secondary problem that it creates a massive information overload a lot of the time, especially if you're using something like a BT, which I'm going to use as an example. Like you end up with these massive behavior trees that are now calculating stuff for goals that then potentially need to be reused later on, plus all the decision making, plus the behaviors in one giant place. So it's literally doing everything a thing, and it becomes so many nodes and so much data that it becomes impossible to read. This is kind of a problem that I have with these all-in-one solutions that say, oh, we'll just provide a single way to handle everything. And it's like, you can't do that, because under any sort of like relatively complex problem set, or just a common basic AAA AI requirement, you're going to drown in data and nodes and complexity with all three things, to the point that now it's like, how do you deal with this? How do you edit this without breaking anything? How do you share stuff between stuff because, customization becomes a big problem. So using a behavior tree as an example, your selectors, excuse me, your selectors are the things that are fundamentally deciding, should I go down a branch or not? And those selectors are the ones that might be querying relatively expensive things like, do I have covers? So I should go into the cover branch, So you end up having a much more expressive and complex selection query mechanism in place, which has a whole set of other problems that I'm going to touch on a bit later. But one of the bigger ones, it becomes really, really difficult to specialize and customize per AI archetype. So if I have one behavior tree that's now supposed to handle all my combat AI, how do I specialize that, right? For my different things, my range versus my melee, my elite versus my regular, my mini boss versus my grunt, right? You have a lot of variation. Maybe you have multiple types of range characters that have different decision making. How do you specialize and customize this? Do you make a tree per archetype, or do you start trying to duplicate the trees into subtrees and then modify the subtrees and then deal with the whole, like, what if the base tree that, changed, or, right? Do you branch in queries, which is another thing that I've seen where, like you say, if, archetype equals grunt, then, go down this branch or block out a whole section of the branch, right? That also becomes a giant mess because now you've sprinkled your archetype all over your tree. Another approach is you try to generalize all your queries to now use very generic information on the archetype. So like the archetype will have flags like can use cover, can do block, can do this, and then your tree is now blocking on those flags. The problem is initially it sounds like a good idea, but then as all the special cases come in, you just end up with like fucking 100 random flags that turn on and off parts of your tree, which again, you get this massive cognitive overload where it's like, I don't understand what it's doing. We had a case like that in Absolution where we realized a flag was never actually being set in code, but was used all over the behavior tree, and it had never once triggered because it was never ever set. So we fixed the bug, but we were terrified of submitting that because we had no idea what was going to happen now, because functionally the entire tree was going to change, and it was used like in 50, 60 places. And those kind of things are very dangerous because, it's very easy to sort of break that binding between, this magic flag and how is this flag used. The other problem is primarily with performance. In a lot of cases with this approach, I'm going to use covers as an example across the board because it's something that's relatively well understood. But very simple example is that we might have multiple behaviors that want to use covers, like one that goes to a cover, one that jumps over a cover, one that may be moved close to a cover but doesn't enter it. Like, they might be different behaviors that want to still use covers. If we were doing this in a behavior tree, the most naive approach would be is like we would have selectors that would basically say query if I have a valid cover, and if I do, record it, blah, 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 and set some flag somewhere that I can use. But we might need to check that in multiple different places, because maybe not all of our cover behaviors are on the same sub-branch, right? They may be in different sub-branches. They may be, one is under range, one is under melee, one is, under kind of move to position, right? Depending how the tree is structured, you might have to calculate this cover stuff in multiple places and multiple times in a frame if one of those branches fails. And that can be really, really expensive. So your naive then approach would be like, okay, well, then we start creating a system to cache the results, and then we share those results across multiple behaviors, which can often add unnecessary complexity to the whole thing, because this is not a systemic solution. This is we had a problem, so we patched with a separate cache system, which again is what the goals fundamentally solve in a kind of elegant systemic way. Another thing is that approach can be super error prone because that cache is generally populated by whatever query ran first. So depending on how it happened, you might get different results. And again, that kind of violates some of the consistency aspects, because one of those queries might be written in a way that only gives me the covers within 5 meters, but then the next behavior needs all the covers within 10 meters, right? you catching that is going to be tricky because potentially the one ran first, correct, and it ran correctly for a while, but then another time the wrong branch triggered, and now your data is a bit fucked. Trying to find that is going to be pain. So again, there's another kind of rule that I try to keep in all of my dev kind of mentality is sort of the single responsibility principle. And so I generally want systems that just do one thing. It's not always possible, but ideally in many cases it is. And you say, this system does this, and that's all it does. And then that data gets sent to another system, and that system does that. And then once that's done, I put in a third place, and that just does blah. And it becomes super clear about what does what, and easy to fix problems sort of in isolation. So sort of the general recap of this. Fundamentally, we want to build a system that converts information about the game state into goals, desires. And then we will build a system that those goals and desires get used with. And then it will select a behavior. And obviously step 3 is we profit and everything's awesome, right? Because everything's easy. So when it comes to sort of the goal generation side, goals and desires are simply a little bit of a piece of information that says, hey, there is a high level thing that I can do or I can use, or it's available to me. All right. So examples of this are stuff like, oh, there's a patrol that I can follow. There's a smart object that I can use. There's a point of interest that would be good for me to look at. Oh, I can react to a sound or an event. Oh, there's an enemy I can fight. Oh, there's an explosive barrel that's available for me to shoot. Right. Those are all examples of things that I can do, I can use as an AI. Now, it's also really, really important to note that the goals and desires, they only specify that something's available or possible to use. They're just things I can do. What they don't do is specify that it should be done, right? It doesn't say, hey, there's an enemy that I can fight, so I need to fight it. It doesn't yet. It just says, there's an enemy that you can fight. You can choose to do that. You can choose to run away. You can choose whatever you want based on the other goals. This is up to the decision maker. What you can do with the goals is you can put some hints. And I use the word hint specifically there because, again, it is not a decision. It's just saying something like, hey, there's like 5 enemies around you. It's preferable that you target this one because that's what the aggro system is saying, or because you're multiplayer and the other player is targeting a different character. So this one's probably the right one for you to target, blah, blah, blah. Again, it's something that you can add extra information, but it is just that you are adding information. You are not making any decisions here. The generation generally is running off of the world data, the world state. So it is run as a stage that says, okay, we run all the sensors. Sensors can fill our knowledge with certain information. We update the world state, blah, blah, blah. And then we run the goal generation that basically says, what do I currently know about the world? What shared knowledge is there in the world, blah, blah, blah. I covered some of this in the previous stream. You can go back for a little bit more detail, but fundamentally, it's run after the sensors to make sure that the goals and the sensors are up to date and the knowledge is all synchronized. So let's just do a very, very dumb example. We have a situation where we have a character and environment. There are 2 smart objects like a campfire and a bench. There's a wall and there's like a patrol and stuff. So let's create some goals. Like imagine we have some goal generators that run and they basically say, okay, I see smart objects. So I'm going to create a smart object goal. This means that there are smart objects for me to use, and that goal will contain the campfire and the bench. We will run potentially a patrol generator that says, oh, I see a patrol near me. It's patrol 34. Here's the information about it. All of a sudden there's a sound. Well, then we might create a React goal that says, hey, there's a React goal, and the reason for reacting is footsteps. The footsteps were here, blah, blah, blah. That might also result in saying we might have a rule in our goal generation that says, hey, if you hear footsteps, that's something to investigate. So we want this character to investigate footsteps. So we will create an investigate goal with footsteps. And so now that character, based on this game state, will have 4 goals. And again, I'm going to repeat myself a fair amount in this. The goals don't mean you should do those things. It means you can. That's up to you to decide afterward. So So in terms of the generation as well, like the generators themselves, they can do three things. They can create, they can update, and they can destroy goals. What's important is that the generation has clear rules. For example, a lot of times a designer will say, hey, I want the AI to react to footstep sounds, but then if he has 3 of them within a short duration, then we need to do an investigation, right, to figure out what's going on. Well, that's a very simple rule, and it's a very simple thing to write. And so we create a generator that says, if I hear 3 footsteps within 5 seconds, and you expose the 5 seconds to a setting file that they can tweak, boom, we get an investigation goal. And we can ask the designer, that investigation goal should be on the last footstep, should it be in the general area? Where should we generate that goal, potentially? You know, simple question, easy answer. Another thing that might be a rule is saying, well, I'm a larger character, like a heavy character. I cannot use low covers, so I am only allowed to use high covers. Well, that's a clear goal. So on my cover goal there, we'll basically have a tick box that says, allow low covers, which we untick for those characters. You know, again, very clear rules. Goals themselves, they might need to be updated. So, for example, I might have a reaction goal that has the footsteps in that example. And all of a sudden, on the next update, an explosion occurs. Well, I need to react to that explosion too. And maybe I haven't reacted to the footsteps. So what I need to do in that point is update my goal and say, okay, I've got a react goal. It has footsteps. I'm not going to do anything with the footsteps. I'm going to just add, hey, an explosion occurred. Here's the details of the explosion. I let the decision making and the behaviors take care of what should happen at that point. I'm just giving you the information of, hey, this is what it does. Additionally, goals might be time sensitive or get invalidated. For example, we might create an investigation goal for those footsteps, but I might have been doing something way more important. And that thing could have taken, I don't know, 10, 15 seconds. I don't want to now finish that thing and say, oh, I heard a footstep and go, you know, deal with that. It's like, no, it's like, okay, after 4 seconds, you haven't dealt with this, we remove it. It's no longer a goal because the information has changed, the world state has changed, whatever. Additionally, certain things like I was in a fight with a target and all of a sudden that target disappeared. I lose my combat goal, right? Because I don't have an enemy anymore. I don't see anything, right? But that leads us to another thing is that sometimes like goals might get converted into other goals. So in the combat target example, as my target disappears, that goal generator for combat might say, hey, I had a combat target. This was the last position that I knew it was at. It's gone now. So my rule says, whenever that happens, I need to create a combat search goal for that target. And we will convert that goal into a combat search goal instead of a combat goal, which then potentially can trigger a search or whatever else in the decision-making side of things. So I did mention the goal generators. Each archetype will have a set of these generators. They can generate, you know, whatever needed, investigation stuff, reaction goals. Yeah, you can add these as you want to your archetype. You can set up settings for them. You can do whatever you need to. This is, again, you do what you need to do. There is a warning with all those things that since the generators can define the set of available actions, they technically do indirectly control decision making, right? If we say that the goals are the things that will drive decision making, obviously me creating and destroying goals will affect decision making. So that you need to be careful where you put certain decisions because, you know, to some degree, the goals are just information about, yes, what's available and what's not. So you are controlling the high level decision making in that regard of at least providing options and not. But you need to be careful not to bleed like moment to moment decision making, like gameplay stuff into there. For example, like the covers, if we want to say limit which covers available to us by distance, there's 2 ways of doing it. One, I can limit that set in the goal generator, right? Or I could choose to do that in the behaviors. Now, it's generally better to do that in the behaviors because some behaviors, as I mentioned, might say, hey, I need covers within 5 meters, covers within 10 meters, covers whatever that is. So the goal generator should just say, what is the maximum that I need to do in like 15 meters? Let me give you all covers. Generally, the cost is not much more, assuming that you're already using a spatial data structure and that kind of thing. You're just doing an archery with a 50-meter radius versus one within like 5 meters or whatever. And then each of the decisions, the behaviors themselves can then say, I only care about the ones within 5 meters. I only care about the ones within 3 meters, what have you. And so again, you're keeping those kind of decision making in the right place, and your goal generator is not making moment to moment saying like, in specific situations, I need to change the distance and blah, blah, blah. It's just doing a very broad face info gathering. So that sort of kind of covers up the goals. If anybody has questions, just ask. We're going to jump right into sort of the behavior selection. Now, behavior selection is kind of I'm just going to go into it and we'll get to that part. Fundamentally, it's a very simplistic thing in that we have a precondition that basically says whether it's available or not, a cooldown, again, that's basically saying whether it's available or not. And we want to have explicit control of the selection. And in terms of like, I know why something was chosen. Scalability is also something that we mentioned is something we want to do. So we want to reuse behaviors, right? We want to be able to sort of like share an implementation of something multiple times without having to do crazy copy pasting or, again, the information overload. And I personally feel that the runtime modification of the decision making at runtime is extremely important and extremely flexible, and is one of the main mechanisms through which you can achieve real kind of scalability. And I don't mean scalability in terms of number AI, I mean scalability in terms of feature set and types of archetypes and kind of richness of gameplay. And the other thing is obviously debuggability. The things that we do not want in the selection is no static prioritization. I don't want to have an explicit thing that says this is, explicitly higher priority than this. I do not want implicit dependencies between the decision-making logic and the behaviors. I don't want the behaviors influencing the decision-making by setting flags that then they expect the decision maker to do something else. Again, this was something that I've seen very common where you run a behavior that then sets a flag that then you expect the behavior tree to jump into another node, right? This sort of implicit dependency makes things really, really difficult to reason about and really, really difficult to debug, and it breaks all the time. I don't want black box selection, for example, like a giant planner, for example, where it goes in and then it spits out a set of things to do, and it's like, okay, what happened? Why? Right? It needs to be very, very understandable. And again, I'm harping on the special cases. It has to handle those scenarios. Coming back to behaviors, I touched on them in the previous stream, so I'm going to go through this a bit quick. Basically, it's just a sequence of actions to achieve some goal. Move to X, plan, attack, animation. Go there, shoot. It is a sequence for the actuation layer. You request something, you wait for it to complete, you request the next thing. Behaviors themselves should have settings that specify certain aspects, distance to move, what speed should I do it at, whatever you want to set up there. This allows that behavior to be reused in multiple different contexts just by tweaking the settings. And I'll do a very brief example of it later. How to author these behaviors? Well, that's up to you. Pick something that you want to do. Again, as long as your behaviors are separate of the selection mechanism, it doesn't matter how they're implemented. You should be able to also manually request them, right? Again, so that they're not tied to decision making. And another very important thing is to have to support failure. A behavior can fail. Like I could be moving along a path, the environment changes, my path now is invalidated, and I can no longer get to my destination. I need to be able to fail, and I need to be able to say why I failed, right? Also, sometimes things fail due to metrics, environmental problems, and that. QA needs that information too to basically be able to properly create a bug and triage it, right? That is really, really important. As I mentioned, they're an action sequencer. That said, they can also be a state machine with multiple action states. So for example, a patrol behavior could switch between follow a path and use a smart object that is set up at a specific waypoint, right? It doesn't need to just be follow a path behavior and then you switch to use smart object behavior, then you fall back into the fall. It doesn't matter. It's like if you have an action that says use smart object, you can call that action within multiple behaviors, right? So be as explicit as you can within the behaviors. That's the benefit. Another thing that's important is the behavior should specify whether they are interruptible or not. There are many cases where certain actions are just uninterruptible because trying to support interruptibility just becomes a giant headache in some cases. And so it's generally better to be able to say like, hey, while you're doing this thing, we're not going to change that until you get to a point in that behavior that is actually uninterruptible. Because if we try to break at any given point, it could end up in a very problematic situation. So it's a good feature to have. You're probably not going to use it a lot, but when you need it, it's there. So in summary, there's generally an execution state of running, complete, failed, and an interruptibility state. Am I interruptible? Am I not? In terms of selection, I mentioned that there's already like preconditions, cooldowns, and those sort of things. So a behavior will basically just cover these things. And there is also additionally a score. This kind of alludes to sort of the utility stuff where, as I mentioned, I think the utility concept of, well, I don't know why I keep saying utility. It's a heuristic. It is just a score of how useful this is or not. That score is beneficial to have. And this is how you would achieve, to some degree, your prioritization. It just isn't static. So when we talk about sort of the preconditions, they are just a set of conditions that need to be met for this behavior to be able to run. That's simply it. Most of the time, they will be tied to one of the goals that you've generated. So if you want to do a behavior that requires covers, you're going to require a cover goal. That said, that's not always the case because you also don't want to generate goals for every random thing out there. For example, like if you find that the character all of a sudden has lost the floor under them, I don't need to have a goal that tells me, hey, you lost the floor, right? I can just have a behavior that says, there's no floor, you should fall, do falling, right? And manages that aspect of it. So you need to balance the goals with basic character state in your behaviors to see what makes sense. Again, think of the goals as very compound things that are kind of like meta information about a lot of the game state. It's like compound info. That said, once you have these aspects in the behaviors, the selection logic is very simple. It just becomes a very simplistic bucket search. And the first stage of that is a binary broadbase. Basically, it just says, is this behavior valid or not? Yes or no? And this is sort of the main thing designers want to control. Like designers, fundamentally, they want to be able to say, this behavior is only allowed when X, Y, Z, right? That's how they think, and that's what they fundamentally want. And that was a huge headache with a pure utility approach, where it's like, well, in this situation, all these scores have to be 0, but in this situation, all the scores have to be 1. And it's like, and then you're behind the scenes writing a lot of if statements to generate random scores and curves that are basically hacked to provide, binary values based on conditions, right? You're hacking a system to do something that it's not built to do. So an example of this is I have a bunch of behaviors. I basically go through all of them and say, hey, what's available for me to use and what's not? And in this situation, okay, melee is available. Cool. Guess what I'm going to do? Very easy. Additionally, they might all fail, right? And then you kind of need a default behavior that sits at the back like an idle, something that is always going to be valid, except the score will always be like 0 or something, so that. So very simple. Either it's valid or it's not. As I said, there's no prioritization that's static. Everything's done by behavior score, and that score is generated dynamically based on the situation, the behavior settings, the character state, will state, whatever. So imagine we do that same example, except this time we have 4 options. Well, this is where that score system comes into effect, and we basically say, cool, we'll generate a score for them. And then we pick the highest score, boom, problem solved, we move on with our lives. In the situation where we have multiple behaviors with the same score, well, it's as simple as selected randomly because logically, I've done the binary thing. These are all available options. I've done the scoring. They have the same score. So that basically means they're equally relevant. So it doesn't matter which one I pick at that point. If it did matter, the scores would reflect that. So we pick one at random, doesn't matter. Second mechanism that we have in the selection is a group. And all that is a way for us to share preconditions across multiple behaviors, right? Sometimes you want to say, hey, do I have a combat goal? If I do, then these are the behaviors that are valid. You know, the behaviors will still check the goal, but there's no need to potentially do a lot of expensive checks along the way as well. And you can bypass even accessing those behaviors and a lot of kind of things. Additionally, there may be other conditions that this group is checking, not just the goals, right? It could be checking character state, health, whatever, right? There is some precondition running there. They just contain also a list of behaviors and subgroups. The nice thing is here, the ordering doesn't matter. It's just a list of other groups, list of behaviors, order, irrelevant. Selection is very simple. When somebody says, hey, give me all the valid behaviors for this group, we just say, cool, preconditions are met. If they are, then I go through each group and I ask that group for its options. And I go through each behavior and I check if that's a valid option and I return back the entire set in that case. If we want to do this in a good UI, it's a very simple thing where we can create certain groups, we can add behaviors to the groups, and that's what we have. And the important thing here is that there is no root or structure. It is just, there's a group, there's some behaviors within a group. We're going to evaluate everything. When we do decision making, we use the groups to sort of do kind of early out or shortcuts, you know, short circuits out of the thing. The other thing that's important is that we can have both groups as well as loose behaviors. You know, sometimes they just doesn't need to be a group. You know, you just put smart object in the root and it gets checked every time. What I mentioned earlier was the behavior reuse aspect. Some behaviors, you know, might be the same behavior under the hood, but it might have multiple instances within your decision making. So for example, I might have a melee attack behavior that has some settings, and then I say, cool, I'm going to use this to define a light attack, which says, this is my attack ID, this is my max distance, this is my tracking stance, and whatever else information I want to do there. And then I want to make a heavy attack that has that, and then I want to set a cooldown on the heavy attack to 5 seconds. So I try to do a heavy attack, and then for the next 5 seconds, it's no longer an option because the cooldown fails, and then I'll just do the light attack. Right? Under the hood, the logic is identical. It's doing whatever the same behaviors. It has some settings that define how it should perform, and the designers have the flexibility of reusing this in multiple places with multiple things. And if you write your behaviors in a sensible way, you can get a lot of mileage from this kind of system. Selection logic is really, really simple, right? While the behavior is running, we just early out. Once it's finished, then we basically find all the behavior options and we pick the best one. Obviously, this one here is ignoring the interruptible state. That's an exercise for you. It's not a hard thing to implement. I don't want to make the pseudocode more complex than needed. Unfortunately, this has a massive problem that there is no mechanism for interruptions. And what do I mean by interruptions? Basically, there's high priority behaviors that have to start while you're doing something else. Things like hit reactions, falling off of something, being frozen or stunned, those sort of things. Those have to trigger instantly, and they have to interrupt other behaviors. So one thing that you could do is you could also run all of this through reactions. You know, like the falling, the frozen, the this, it's like, oh, react to the ground missing or react to being stuck. It's like, you could. I don't advise doing that. Keep everything more explicit. It's going to make life a lot easier for you. I call these high priority behaviors because they're not interruptions or reactions. They could be different things. They're evaluated every frame. Again, only if the current behavior is interruptible. And if we find a valid high priority behavior, then we trigger that interrupt and we shut down the current behavior and switch to the higher priority. In the UI, that's represented with a group that's always present, that has no preconditions, that is flagged as a high priority group, and that's evaluated every frame. So the selection logic now simply becomes check if we have a high priority behavior that's valid. If we do, let's pick it and run it. So let's go through an example of the whole behavior selection aspect. We have two characters. They want to fight each other. There's a cover in between them that they can't cross. And so for red, we're going to basically say he has a cover goal and he has a combat goal. In this situation, we're going to use a very simple kind of behavior selector setup like this. And we're going to basically go through each element and say, okay, what should we do? High priority is always available because it always has to be evaluated. And we'll go to the reaction group and they will say like potentially like, do we have a reaction goal? And it's going to say no. So we don't do anything else. Do we have the floor? Yes, we do. So falling is not a good option. Smart object. Nope, not a good thing to do. What about the search? We don't have a search goal, so we don't evaluate that group. Combat. Well, we do have a combat goal. Okay, so that's valid. Melee, valid. Then we go to light attack and we say, well, I can't reach my target. I don't have a line of sight, like a nav mesh line of sight. There's an obstruction. Melee is not a good option for the light attack. It's not a good option for the heavy attack. This is where you could put a group if you wanted to in advance to do sort of a line of sight check and sort of like short circuit that out. Again, how you set this up, depending on your game. We go in the range attack, again, valid. Ranged attack is valid. Grenade attack, valid. Revive target, not. Chase is not. So now we have two options, range attack and grenade. Cool, easy. What do we do now? Well, we apply the scores and we pick the one with the highest score. And that's how the behavior selection fundamentally works. It's a very, very simplistic approach to doing this. Another element to the selection is reselection. So what this does is occasionally while I'm running a behavior, I might want to just reevaluate all the other options and see if there's a better thing for me to do, because sometimes it's not a high priority behavior, right? Something that has to be checked every frame. But it's also something that like is high priority than what I'm currently doing, but I don't want to wait to finish my current behavior to pick it because my current behavior might be never ending. Like I'm idle and all of a sudden I've decided I want to use a smart object. I can't do that. So with the reselection is a mechanism for us to basically reevaluate all behaviors and see if we have a better choice than what we're currently doing. How that's triggered, again, is super specific. It can be done every time a new goal is created. We reevaluate our current selection and say, hey, should I be doing something more important? That's a good approach. Or, hey, every couple of seconds, let me check, because maybe based on my new goal, a cooldown has expired and now it decides maybe I should be doing this other thing, right? This process doesn't actually cancel the current behavior. It just checks for a better one, right? And if that better one is, then it cancels it, right? This process in itself isn't saying, okay, stop what you're doing, let's figure out if there's something better. It just basically says, if I find something better, then we'll do an interruption. Another important thing is you should not allow reselection of the same behavior. The behavior should just not exit. You should just handle any updates to the goal internally. So for example, if I start reacting to a footstep and an explosion occurs, I have that information in my goal, and all of a sudden I can check my goal and say, hey, something happened that's critical versus a low priority reaction. And at that point, I can either say, okay, I need to switch the bar to what I was doing or cancel what I was doing and re-trigger the reaction. Or maybe I just say, okay, look, I'm already doing a reaction. I just have to ignore this other one, right? Game specific stuff, but handle it within your behaviors. Do not cancel a behavior just to restart that behavior, because you're going to deal with a lot of cancel, like cleanup state and restate the same state. You're just looking for a lot of pain there. So now to get to sort of the really kind of, for me at least, the cool part, the stuff that I think is where the real kind of scalability and power comes in, is that this system allows you to do dynamic behavior modification. Because there's no prioritization ordering structure to any of the selection mechanism, it allows us to basically add and remove behaviors at runtime, right? Because it's just behaviors. Like each behavior node has a unique name within the context of that character. So for example, in the previous case where we had the attacks, we have something like combat, was the main group. Then we have the melee attack group, and then we have light attack. This assumes that names are unique within their kind of context, but that's easy enough to enforce in a tool. It also then allows us to disable a node by path at runtime. And it allows us to inject nodes by path at runtime. So for example, we have a setup like this, where we have a combat group and a search group and blah, blah, blah. I can say, hey, I need to disable the range attack. And boom, it's gone. Nothing else needs to change, right? Because it doesn't affect the goal generation, doesn't affect anything else. It just says, I do not want that behavior to be available anymore. Then we say, cool, I need to inject a new AoE attack into combat attack, and well, we stick it in, right? Again, there's no dependencies between anything, ordering or anything like that. Cool. And then maybe I wanted to actually inject a new ranged attack into combat attack that has completely different settings. Because of that, there's a specific special case that this is a elite enemy that has a range attack that has different attack values or fire rates or whatever you want to do. And so you can inject, and now you've basically modified a behavior selector at runtime. This allows us to package up these modifications and apply them as a set to a given state. This actually truly allows for composition style approaches to controlling the decision making in the feature set. It allows us to handle those special case situations without this painful explosion. We have the AI and we say, okay, in this situation, I need these modifications make your behavior. Turn off these behaviors, add these new behaviors. That simplifies the logic a lot. Additionally, it's stack-based. So you basically just apply these kind of behavior modification packages on top of one another. So it allows you to apply as many as you want. It just stacks up and you get the final result of that stack. It also means you can remove a package at anywhere in the stack, right? Again, I hope a lot of you can kind of start to see the flexibility this will allow you to build within your stuff. So one thing we also built for the designers to try out is basically it was like a stacker that they could basically say, hey, I want to take this base set of stuff and then I want to apply this and this and this and this and what happens. And it would show them, hey, there's errors because you're trying to disable something that doesn't exist, or you're trying to inject something that's already there, blah, blah, blah. And it will show them the final state of what's enabled, what's disabled, what the settings are, right? We also had an in-game GUI version of that. So at any given point, dev QA or a programmer or a designer could pause the game, pop that open and see exactly what state that AI is in. It was really, really simple to understand exactly what was going on with this setup, because it was just simply, these are the behaviors I have and this is where they came from. So where is this kind of useful? Well, imagine I have basically an elite ranged enemy in my game. It works everywhere I want to do it, but all of a sudden the designers say, hey, we're going to do a special mission where we're going to have a bunch of mind-controlled characters that are controlled by a boss, that if you take down the boss, that they're free from their mind control and this and that. And we want custom behaviors for those mind control characters that now we're going to change how the elite handles, or we're going to change the way that they, they're fighting the mind control so they're less efficient at shooting and blah, blah, blah. Right? So we want to modify some behaviors, some settings. Well, we just plug in this package on top saying, well, okay, now it's mind controlled. Boom, behaviors are overwritten. And they say, okay, but you know what? Now we were thinking that we're going to take these characters and we're going to put them in the context of a bank robbery. And then we need a couple of them to hold up the guards and deal with the civilians. And a couple of them are threatening tellers and blah, 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 whatever. And we want to give them specific kind of roles and blah, blah, blah. Well, then you just add the bank robber behaviors on top of this system, where it's like, okay, now it's a bank robber. Maybe that set some extra flags and whatever else on there and add some new behaviors in there. And okay, one thing I am forgetting to mention is that when you apply this package, you also sometimes have to change certain aspects of the character's flags, like set some extra tags and change a few values in their agent state. But again, it's packaged up, and because it's stack-based, it's very clear of what's happening where. And it's fundamentally changing core elements like set of tags as like elite, range. Now he has a new tag that says bank robber that we can match to smart objects or whatever else. And as I mentioned, you could also remove these things. So potentially you kill the boss in some way, and then the mind control breaks, and now you want to remove the mind control behaviors. You can do that, and you can still keep the bank robber roles, right? Some other examples of this sort of thing is that in the basic case of us just building our basic archetypes, we can start from a base combat AI, and then just add, well, you have range behaviors, you have investigation, you have melee. Oh, you're a veteran, so now you get the veteran ranged on top of your basic one, right? So it is a composition approach where we can sort of remove, add behaviors, tweak settings, adjust stuff in a very simple way. And it's a very kind of manageable way of dealing with this information because it's very explicit, right? If you open the veteran package, you say, okay, veteran adds 4 behaviors and it overrides this one with these settings, right? There's no ambiguity. There's no searching for all the places that the veteran was set up in the giant behavior tree and where are the ifs, where is this, is it in the conditions, is it here, which branches are just for the veteran, which ones are just for the elite, what subgraphs do I have to look, all that kind of shit. The other aspect is for this role assignment scenario. This is what I wanted to do in that Hitman project where every level was a different environment. It was an airport, then an opera house, then a this, then a that. You know, we wanted to basically say, I'm going to put a bunch of civilians in the level. I'm going to say, you're a shopkeeper, you're a TSA agent, you're a waiter, you're a gate agent or whatever. And they would add behaviors. They would set up things about what's mod object news, this kind of thing. So we could basically assign that dynamically without having to create a custom AI brain or what have you for each type. Another option is boss buffs. A boss could basically trigger an area-wide buff that injects new behaviors or adjust behaviors across the board for any enemies nearby. You could do that by putting those behaviors in the base of every AI and then hoping that they're on a boss. But again, that becomes messy because it might be a very special case scenario that you want to deal with this. The same thing for these scripted encounters. There might be special cases where all of a sudden all the range characters within a specific encounter can't use their range weapons anymore. Now they have to do a couple of melee attacks, right? You don't want to build that into the base system. You just want it for that one special case place. And this kind of mechanism allows you to do that. Hopefully you can kind of see the benefit of this and kind of the general simplicity of the whole approach. As I said, it's all relatively high level. It's more just to spark some ideas and potentially let everybody run with this. Hopefully people found this useful. Yeah, if there's any questions, now's the time. The question is, the stacked more specific behaviors just adds new ones to the groups rather than placing the core AI ones. They just get selected because of the scores. No, what the modification does is actually it can remove any behavior in that stack that's already there. So if that behavior with that name exists, it can be disabled, it can be overwritten. Right, you have complete control. So you can go in and you can disable every single core behavior if you want. You have the flexibility to do that. All this is doing is it's basically saying you have a bunch of groups and a bunch of behaviors, and you have a system that basically says, remove those groups, add those behaviors, disable this behavior, overwrite that behavior, blah, blah, blah. Right, there was mechanisms to disable entire groups as well and those kind of things, or insert new groups and that kind of thing. It's just a mechanism to dynamically author this selector, whatever nodes. You have complete freedom to do what you need. All right, well, I guess there's no more questions. So I managed to keep it under 2 hours, so that's good for me. Hope you have a great weekend, and cheers.